Alright, now we're going to combine the idea of not with the idea of or. So sometimes we need to use both the complements principle of counting, which is the idea of not, and the additive principle of counting, which is the idea of or, to do these problems. These problems can be a little difficult, so take your time, slow down, and really ask yourself all the questions. Does order matter? Are repeats allowed? How many parts will the job take? 12. Among the 2,598,960 possible 5-card poker hands from a standard 52-card deck, how many contain at least one spade, but not all spades? So we see this phrase "at least," which drives that we begin with A, U, A prime. A. We want 5-card poker hands, so 5 cards, at least one spade, but not all spades. U is any 5 cards. A prime is 5 cards, but the things that are complete opposite of this. So 5 cards, at least one spade, so we would say no spades. It says up here in A prime, not all spades, so we could do 5 cards, no spades, or all spades. Because no spades is the opposite of at least one, and all spades is the opposite of not all spades. So N of A equals N of U minus N of A prime. So all combinations here. Remember, every time we play poker, we're talking combinations. Order doesn't matter, and repeats aren't allowed. So any 5 cards would be 52 C5 minus A prime has this or in it. And there's 2 things that can happen. Right? So we're going to use parentheses because we have 2 options. Our first option is no spades. Well, we still need 5 cards, so it's still C5, but we're going to take the 13 spades away and have 39 cards. So this right here would represent no spades. Or, we've said is addition, so we're going to have a plus sign. Or what if we had all spades? Well, we still need 5 cards, and there are 13 spades. So this is all spades. Right? So with your calculator, you're going to find these answers and add them, and you're going to subtract them from this. So our final answer is 2,021,916. Given the set A, B, C, D, E, F, G, H, I, J, how many of its subsets have at least 3 elements? A is subsets with at least 3 elements. U, all possible subsets. A prime, subsets with less than 3 elements. Alright, so we got to cover a couple of things here. Subsets with less than 3 elements means no elements, 1 element, or 2 elements. If you want to come up with all possible subsets, that's back from Chapter 2 when we learned the formula 2 to the nth power, where n is the number of total elements in your set. This is a set, And the total number of elements are just counting all the letters that you see. So n of A equals n of U minus n of A prime. So n of U, it simply uses this formula 2 to the nth power. There are 10 letters here, so 2 to the 10th power. Minus, we see an or sign, so we're going to do some parentheses. Now remember when we talked in Chapter 2, the idea of a subset, we said order didn't matter. So it doesn't matter how the letters are written in the set. We also said that it didn't make any sense to write a letter down more than once, so repeats aren't allowed. So if I want to do how many subsets have no elements out of 10, it's a combination. It's 10C0 plus 10C1 for how many subsets include one element, plus 10C2 would be how many subsets starting with 10 letters would have 2. If we work this out, we get 968. Last one. If you toss 7 fair coins, in how many ways can you obtain at least 2 heads? A, U, A prime. A is 7 tosses at least 2 heads. U, 7 tosses. What are all the things that could happen if you toss the coin 7 times? A prime, 7 tosses with less than 2 heads. Now that means this time 0 or 1. So n of A, n of U, n of A equals n of U minus n of A prime. You can see how these problems are a combination of not and or, because it is not because it's an at least problem that requires A, U, A prime, and it's an or problem because these problems that we've been doing, every time we do A prime, we have options. It's not that only one thing doesn't work, it's that multiple things don't work. So, 7 tosses. Well, what can happen each toss? Can't you see heads or tails each toss? So you could see heads or tails across 7 tosses. So the total number of things or outcomes you could have is 2 to the 7th, minus parentheses. Well, let's think about this. If I have no heads, doesn't that have to be tails, 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 tails? There's only one way. Right? Or if I get 1 head, can't that be heads somewhere in any of those 7 positions? So there's 7 ways to get an option that has, so here's an example, head, and then you could have 6 tails, but that head can move around. We get 100, it can shift, that head can shift around. So we get 120.